Hello friends, in this video, let us have a discussion on linked list versus array. So see an example for each. We have array with elements 10, 20 and 30 and linked list with elements 10, 20 and 30. Now let us focus on the memory locations where the elements are stored. In array, we can see that the elements are stored in contiguous memory locations. See 1024, then 1028, then 1032 like that. But is that so with linked list? No. The linked list elements are stored in random memory locations which are linked together using pointers. See, we have 1024, then we have 2028, then we have 3032. But each node has a pointer pointing to the next node. Now, let us discuss about the kind of memory allocation. So for arrays, it is static memory allocation. That is, the memory is allocated at compile time. So we need to specify the array size and it will be fixed throughout the program. That means we can't change the size of the array at runtime. And the memory will be allocated in the stack section. See an example. Int ARR of 5. Now the size of array will be 5 and it will be 5 throughout the program and we can't increase the size then. And what about linked list? Using linked list, we can add as many elements as we need at runtime. That is, here memory is allocated dynamically and it will be allocated in the heap section. We can add more elements based on our need at runtime. Now let us discuss about accessing elements. So in an array, elements can be accessed directly using the index value. For example, we can access the third element using ARR of 2 and its time complexity will be order of 1. Meanwhile, in linked list, we need to traverse the list from the beginning to find the element. That is, if we need to access the third element, first we need to go to the first node, then get the address of second node and visit the second node, get the address of third node and visit it finally. If the linked list has n elements and in the worst case we need to traverse the linked list till the n to find the element. So the time complexity will be order of n. Now let us discuss on basic operations like insertion and deletion. So in arrays, insertion and deletion operations take more time because after inserting or deleting an element, we need to shift all the other elements. See an example, then it will be clear. Here we have an array with elements 10, 20 and 30. Now, if we need to delete 10, after deletion, we need to shift all the elements one position to the left. Now, if we need to insert 100 at index 0, we need to shift all the elements one position to the right and then only we can place 100 at index 0. And for linked list, insertion and deletion operation is faster compared to arrays. For example, let us say we need to delete the element 20. We can simply make the first node point to the third node instead of second node. So we will get like this. Similarly, if we need to insert the element 100 after 20, we can simply set node with element 20 pointing to new node and new node pointing to node with 30. So these are some basic differences between arrays and linked list. So we discussed about memory allocation. Arrays are allocated contiguous memory at compile time and the memory is allocated randomly in linked list at runtime. So we can make the memory size grow or shrink based on our need in linked list, but it is fixed in arrays. Also, we can access arrays easily using indices, but it is difficult in linked list. An insertion and deletion operation are slower in arrays, but compared to arrays, it is faster in linked list. So that's all, and in the next video, we will discuss about applications of linked list. Thank you.